recording through. So here I am going to show you that how will you take the reading in this experiment. Here already I have explained that for different values of x, by introducing different values of resistance in the resistance box, which we have represented as capital X, we will determine the null point by touching the jockey at the different points of potentiometer wire. And when null point will be located, its distance from A will be recorded, that will be taken as L. So once we will introduce 1 ohm, determine small l, then for 2 ohm, 3 ohm, 4 ohm and 5 ohm we will do. So see here, you can see here that how will you introduce 1 ohm. So you can see this is the resistance box. In this resistance box we will take out the 1 ohm key, but rest all the other keys should be tightly fixed. It's clear? It should be tightly fixed. And then you close the plug key here. Here plug key is closed. Now touch the jockey at the different points. First you see whether it is showing deflection in opposite direction or not. You can see here. Here on touching at the end A, it is showing deflection in anti-clockwise direction. You can see in anti-clockwise direction. It's clear? And on showing at the end B, here it is showing deflection in clockwise direction. Means it is showing the deflection in opposite direction. Opposite direction deflection it is showing. It's clear? Here you can see that in the undeflected position, the needle of the galvanometer is 2 division towards the left from the center. So we will take that point at that line as 0. Means on touching the jockey, undeflected position will be the same position at which it is presently there. It's clear? Now I am going to show you for 1 ohm. For 1 ohm I have introduced here 1 ohm key, and then I will touch the jockey at the different point and you see the deflection in galvanometer. So see here, when jockey is touched here, you can see it is showing deflection. Now at which point once again the deflection becomes 0. So it has become, once again it has come to the 0. Now if I ask to show you this position, what is the null point? You can see here what is the null point. Null point is nearly 32 centimeter mark. It is nearly 32 centimeter mark. If I say it is 32.2, more closely I am bringing it. You can see here it is 32.2. You will see the position of the knife edge of the jockey. 32.2. It's clear. Now, in the same way, we will record for 2 ohm. So now I will introduce 2 ohm here in the RB. You take out 2 ohm plug and close 1 ohm plug. Means now only 2 ohm plug is taken out. 2 ohm plug is taken out means 2 ohm resistance has introduced. Once again you locate the null point by touching the jockey. You show at the jockey. Here I am changing the position, simultaneously show at the galvanometer. Wait. Now it has reached here. Now see here. If I lift the key, once again needle will remain here only. You can see here. I lifted the key, needle is at the same point. So what is the null point here? You can so here null point is at, it is 49 centimeter. 49 centimeter, that you can take 49.0. 49.0. So this I am going to write, these two observations I am going to write. First was at 32.1 and this is 42.0. 32.1 and 49.0. Now I will do for 3 ohm. So for 3 ohm, you take out 1 ohm plug also. So now 3 ohm will be introduced, all other should be tightly fixed. And once again in the same way you locate the null point. You can see here where will be the null point. Null point will be this. You can see it is nearly knife edges before 59. It is before 59, 58.7. You can see here 58.7. You can see. It's clear. So it is 58.7 at 3 ohm. Then at 4 ohm. For 4 ohm, you take out these 2 ohm. This and this are 2 ohm. This is 2 ohm, this is 2 ohm. 1 ohm you fix. So 2 plus 2, 4. 4 ohm is taken out. Once again you locate the null point. You show simultaneously both the things, scale as well as this also. Both the things. You can see here. Now you bring more close to the galvanometer. Now galvanometer is needle is at 0. It is at 0. It is 65.3. 65.3. It's clear. So it is 65.3. Earlier it was at what ohm? For 3 ohm it was 65.3. And for 3 ohm it was 58.7. Now we will take out at 5 ohm. So you fix all the keys and take out 5 ohm key. You can see here, this is 5 ohm. When you will take out 5 ohm key, and once again you determine the null point. So you simultaneously show both the things. Okay. Now galvanometer needle is at 0, and at which mark? You can see here it is 72. I am showing you it is 71.7. 71.7 centimeter mark. So this I am going to write. Now you show on the board 71.7 centimeter mark. Now after this we will calculate the values of y. So you can see here So now I am going to calculate the value of y, and y up to 1 decimal place you have to calculate. So see here, these are the values of L. X values are this. So first will be 100 upon 32.1. It is 3.11. So you will write 3.1. It's clear. Then at 2 ohm. So 100 into 2, 100 into 2, 200. 200 upon 49. 200 upon 49. So it is nearly 4.08. 4.08 in one decimal place, 4.1. Then 100 into x, 100 into 3, 300. 300 upon 58.7. You can see here 300 divided by 58.7. So it is 5.1. It's clear. 5.11 it comes out, so it is 5.1. Then 100 into 4. 100 into 4. X is 4 ohm now. So it is equal to 400 divided by 65.3. So this comes out 6.12. So that you will write 6.1. And then for 5 ohm, this is 500 divided by 71.7. This comes out 6.97. 6.97, you can write 7.0. After this, we will plot a graph. Stop. So now I am showing to you how will you plot the graph. So here you have to plot y versus x. Means on x-axis you will plot x and on y-axis y. It's clear. So here values of x are 1, 2, 3, 4, 5 and values of y are also coming in that 1, 2, 3, 4, 5, 6 like that. So see here already in the question it is stated that you have to take the origin 0, 0 and why? Because we have to find the intercept. That's why we have to take the origin at 0, 0. So on x-axis this is 0, 1, 2, 3, 4, 5, 6, 7. On y-axis also it is this. Here value of each division on y-axis is, each small division on y-axis is 0.1. It's clear. So if you have to plot corresponding to this x value, y equals to 3.1. So how will you plot x equals to 1? Each this 3.1 means this point. This will be the 3.1. It's clear. Then 2 ohm. You can enlarge. For 2 ohm it is 4.1. 2 ohm it is 4.1. It's clear. Then for 3 ohm you have to plot 5.1. 3 ohm it is 5.1. So see here 3 ohm is this and 5.1 is this. Then 4 ohm it is 6.1. 4 is this, 6.1 is this. And then 6 ohm, 5 ohm it is 7. 5 ohm is this and for this it is 7. Now you will draw the best fit line. Best fit line means which passes through maximum number of plotted points. Now I am showing the plotted points from this distance. From here you can see plotted points. This. These are the plotted points. At 1 ohm it is 3.1, 2 ohm 4.1, 3 ohm 5.1, 4 ohm 6.1 and 5 ohm it is 7. You can see here. It's clear. These are the readings. 90. Now we will draw the best fit line. So see here what will be the best fit line. So here this is the best fit line which passes through maximum number of plotted points. After that you will encircle these points. Will encircle these points. Then we have to determine the value of y-intercept. So you will produce back this line और वो point जहाँ पर ये y-axis को मिले. It's clear? Because we know that at y-axis x equals to 0. So I am trying to show you this here. When you will produce back, it is meeting to the y-axis at this point. So what is y naught here? Y naught is 2.1. It is 2.1. This is the value of y naught. Means what is the y naught? Here I am writing y naught is 2.1, and what is the unit of this? Ohm per centimeter. This is the value of y naught you have calculated. It's clear? After that, we have to determine capital R and their mean for these three values of x. So you can make a separate table here. You will take the observations, only those observations, but table will be separate. Here this is x in ohm, then here it is L in centimeter, and then capital R equals to 100 minus L upon into x upon L. Now see here, what will be the unit of this? 100 minus L will be in centimeter, upon centimeter it will be cancelled, x is in ohm, means it is in ohm. Now what are the values of x here? 2 ohm, 3 ohm and 4. For these values of x you have to calculate R. So what is when x equals to 2 ohm, L equals to 49 centimeter, 49.0 you will write. 3 ohm it is 58.7, then 4 ohm it is 65.3. Then we will calculate it one by one, and we have to calculate it and find the value up to 1 decimal place. Where is the calculator? This. So you can see here 100 minus L, 100 minus 49, that is 51 into 2. 51 into 2 divided by 49. It is 2.08. You have to write only up to 1 decimal place. Here capital R up to 1 decimal place. So you will write 2.1 ohm. Then 100 minus 58.7, 41.3 into 3 divided by 0.7. This is 2.11, that is 2.1 ohm. And then at 4 ohm, 100 minus 65.3. This is 34.7 into 4 divided by 3. This is 2.12, so 2.1 ohm. So what is average value of R? Mean value of R. So when you will take out average value, it will also be 2.1 ohm. So in this way you will do all the experiments which are based on the Wheatstone bridge, and there is a very great possibility of this experiment on the Wheatstone bridge in 2021, because from last 2 years, 2019, 2020, that is 2020, the questions of the experiment was based on the Ohm's law. It's clear. Thank you.